Welcome back to my YouTube channel. In the previous video, we discussed about vector databases, and in this particular video, we will build our own vector search engine from scratch. Let's jump straight into the tutorial. Hi, welcome back to the video again. So I have already installed all the prerequisites needed for this project, and I also created this virtual environment so that we can start from our main folder. I'm also going to convert it into a package so that we can import files from other packages as well. I will also create the main file, which will be responsible to convert text into vectors, embeddings. Okay. The library that I'm going to use to convert the text into vector format is a sentence transformer. I found this on Hugging Face. Now let's create the embedding class. And then I will also create the instructor. Define the model that we are going to use. Now let's write the method that is going to actually convert text into vector format. So I'm going to name it encode. It is going to receive the object itself and the text. Now let's create a variable that is going to store all the vectors inside. Model encode. I will pass the text. I will also pass the normalizer. I will keep it true. And now let's return the data. And the reason I'm using a list, because the encoder is not just going to encode a single list or a single piece of text. As the data grow, it will create multiple chunks. So I think the list will be very beneficial if you use the data structure here. And if you notice, I did this method to V because sentence transformer return the data in NumPy array, which is not ideal if you want to expose this data to FastAPI. That is why I also created this, converted this data, raw data into list format. And now let's try if it's actually working or not. I will create an object from embedding. I will run a method. I will pass my name is Abdul. And now simply let's print it and see what it returns. It will actually activate the virtual environment and then it run it. Okay. Oh, sorry. By mistake. And then let's try again. Oh, sorry, bro. Sorry. Oh, perfect. So it has perfectly returned these vectors in the list format. And then we can pass this data to our semantic search engine to actually find the similar chunks. That is the first step. And then let's move to the next step. Our first part is done. Now let's move to the next part, which is creating a search engine. Let's create a new file, name it search engine.py. Let's import the class that we have just created, embeddings. So I will just write dot embeddings import embeddings class. Now let's write our own semantic search engine class so that we can use this important class inside it. Let's define the constructor. Same steps that we did in the previous class. We will define our embedder, which is going to inherit all the properties that we have defined in this class. Embedder and embedding. Now let's create another variable which is going to store all text in plain English format that we are going to pass through it. And also create another variable which is going to store all the vectors. Okay. Now let's write another method which is going to process our documents, our data. That data is going to be passed through this class, and this class will create embeddings like this or vectors like this. So let's write a document. It is going to receive cells, the object itself, and the text. Let's turn off the auto completion for now, since we are learning. Okay, let's turn it off. Keep it 30 seconds, 30 minutes, sorry. Let's store the vectors in self.embedder.encode. Let's pass text. Let's extend self.text.extend the text. And I'm just going to justify why I use extend here, not append. I will tell you why. Self.vector.extend vectors. The reason I'm using extend here, because remember, this class is going to return list. If I have just used append, then it will create a new list side and the list. So that is not going to be a proper data format for us. That is why I'm going to use extend here. And now let's define the search method. So I will just write semantic search, which is going to receive the query, the object itself, and the limit, because the data will be in hundreds of numbers. So I want the only top 5 or whatever the limit is. The query will also be converted into vector format so that we can find the similarity. Self.embedder.encode. I will pass the query here. Query will be in the list format. And I'm also going to, because the data will be, the encoder will encode this data in this format. So my query will be at the 0 index. That is why I have put the 0 index here. Now let's calculate the score. For the score, I'm going to, let's import a NumPy. NumPy is NP. Let's calculate the dot product, which is going to be the query vector and the self dot vector. And I'm also going to return the top 5 vectors based on the limit that I have defined. So let's write top 5. Okay, top results, let's say. np to arg.sort. And if you see, I have used this arg sort, which is completely different from the regular sort algorithm. It returns sorted data, but it also returns indices so that we can also track the vector where it came from. So I will pass the score. It will also store the data in ascending form. So we want basically in descending order. So we want the top chunk to be the highest score. So I will just reverse it, and I will also define this limit, and I will just say limit. And now I'm simply going to return the data, return, and this text, which is going to be text and self.text I, and score, which is going to be round float score. I say score, which is going to be I. And I'm also going to return the 4 indices, 4 decimals, which is going to be 4 and 4 I in top results. The second step is also done. Now let's move to the third step, which is going to be creating our own API so that we can test it. Now, this is going to be our last step in which we are going to load the data, and then we will also connect all these things together, and we will expose the FastAPI endpoint. To let's create a file, name it sample data.py. This is going to be our actual data that we are going to test. Let me copy the data. Okay. Now let's go create the main file that is going to be responsible to connect these all things together. For this, I'm going to import FastAPI. FastAPI. I'm also going to import sample data, sample document, sorry. I'm also going to import my engine, which is going to be search engine. What was the name of our engine? Semantic search engine. Let's also turn this off. I don't want this. And now let's create our engine from the main class, which is going to be semantic engine. Let's pass the data through it. Add document, which is going to process our document. And now let's create a fast API endpoint so that we can actually pass the data. To get app is equals to fast API. Now app.get search def search. It is going to receive query, the limit, which is going to be 5. And we are going to return engine dot search, semantic search. And I'm going to pass the query, and the limit is equal to limit. I think that's it. And now let's see if it's actually working or not. So now let's run the fast API endpoint and see if it is working or not. So the command is urecon. Our data is inside vector search engine man, not app. Now let's test it. Let's go docs. Okay, it's working now. Okay, let's take something from here. Let's copy this, paste it here, and execute. Oops, I think we ran into an error. Must be integers. Let's try this. Maybe. Let's try this one. And let's see. Let's try it again. Try it out. Paste it. Okay, results beautiful. So as you can see, it has returned the top chunks with the similarity score, and also other chunks as well with the similarity. So as you can see, I copied this text from the very first line with this thick out. Yeah. So our app is working very fine. Let me try with another query. Let's try. My name is Abdul Samad Kila. Let's see how it goes. Yeah, it was not able to find. That is it from my side. I hope you have enjoyed this video, and if you learned something new, write it in the comment below, and I will also put this repository in the description so you can check it out and play it with yourselves. See you in the next video, inshallah.